integrals. Before starting the Riemann Steiltjes sum, a little bit some basic, that is the set of measure 0. So that means the study of the integration theory, particularly the Riemann integral, the concept of that bounded function as a Riemann integral. Encounter the concept that the bounded function as a Riemann integral, provided it is continuous at almost every point. That is continuous almost every point. The meaning of the almost every, that means it's defined the terms as the set of measure 0. So what do you mean by almost every? It is called the set of measure 0. So what's the definition of the set of measure 0 means? If j is any interval of the real number, j என்றது any interval of the real number, and denoted the length of j is called the mod of j. Suppose subset E of R1 is said to be measure 0. R1 it's a real line, one dimensional space. The subset is said to be measure 0 now. If for each epsilon greater than 0, there exists some finite or countable number of open intervals, I1, I2 and so on, such that E, the subset of the R1 E, is completely contained in union of the finite or countable number of open intervals. Okay, and the sum of the union of sum of the finite or countable number of finite intervals, length of the intervals, each and every one length எடுத்தீங்கன்னா இது எல்லாத்தையும் sum பண்ணீங்கன்னா should be less than epsilon. Okay, thus therefore E is the measure 0. E is of measure 0. Okay, E is said to be measure 0. So E என்றது measure 0 அப்படின்னு சொல்லணும்னா E என்றது subset of R1. Anything that is E, this may be interval like that. So that is of measure 0 அப்படின்னு சொல்லணும்னா for the each epsilon greater than 0, when you choose any positive integer, that is epsilon, there is a finite number of countable or finite number of open intervals. Finite number of open intervals or something. அதனுடைய யூனியன் பார்த்தீங்கன்னா யூனியனில் இந்த செட்டு கம்ப்ளீட்டாக இருக்கணும். ஓகே, the set completely contained in union of the something. இது எல்லாத்தையும் ஆட் பண்ணிங்கன்னா this interval length ஆட் பண்ணிங்கன்னா that is should be less than epsilon. Total length of the interval is less than epsilon. Then E is said to be measure 0. That means E is measure 0 means, from the definition, E can be covered by union of open intervals. Union of open intervals alla cover ஆகுது அப்படின்னு அர்த்தம். Union of open intervalsல E என்றது கம்ப்ளீட்டாக கண்டெயின் ஆயிருக்கு. So that means in terms of covering யூஸ் பண்ணா E can be covered by the union of open intervals whose length is add up to less than epsilon. அதனுடைய length பார்த்தீங்கன்னா add பண்ணணும், less than epsilon வர வரைக்கும் add பண்ணணும். So that is the definition for the E of measure 0. Okay. So the example பார்த்தீங்கன்னா a set consisting of one point. A set consisting of one point as measure 0. Any finite set of points as measure 0. And the rational numbers Q form a countable set of measure 0. and non-empty open intervals, that is how much small that is non-empty open intervals is never of measure 0. Non-empty open intervals is never of measure 0. And the countable union of measure zeros, that is each of the subsets E1, E2 and so on of R1 is of measure 0, then E1, E2 எல்லாமே measure 0, then union of En is also measure 0. Union of En is also measure 0. That is the small proof. And countable sets have the measure 0, that is every countable subset of R1. Every countable subset of R1 has measure 0. Okay, these are very important properties on the measure 0. And almost everywhere. Now come to the point, what is the meaning for the almost everywhere? Very important concept in measure 0. A statement is said to hold at almost every point of the A comma B. Almost every point of the A comma B. ஒரு A comma B ன்னு ஒரு இன்டர்வல் எடுத்துக்கிறோன்னா அதில் ஆல்மோஸ்ட் எவரி பாயிண்டில் ஒரு ஸ்டேட்மெண்ட் ட்ரூவாக இருக்குது அப்படின்னா அதுதான் ஆல்மோஸ்ட் எவ்ரிவேர் இன் A comma B ன்னு சொல்லுவோம். If set of points of A comma B at which the statement doesn't hold is ஏதோ செட் ஆஃப் பாயிண்ட்ஸ், ஒரு செட் ஆஃப் பாயிண்ட்ஸில் A comma B ஒரு செட் ஆஃப் பாயிண்ட்ஸில் the statement doesn't holdன்னு அர்த்தம். அதானே மீனிங் தட் இஸ் a set of measure 0 almost everywhere means ஒரு ஆல்மோஸ்ட் சம் பாயிண்டில் செட் ஆஃப் பாயிண்ட்ஸில் the statement true. அப்புறம் மிச்சம் இருக்கிற பாயிண்டில் the statement doesn't true. The statement வந்து ட்ரூ இல்லை. That is doesn't hold is of measure 0. That set of point is called the measure 0. So the almost everywhere na, that is the almost every point la the statement is true ன்னு அர்த்தம். So example பார்த்தீங்கன்னா f is continuous at almost every point of the A comma B. இதுக்கு என்ன அர்த்தம்? f is continuous at almost every point of the A comma B na, if E is the set of points of A comma B, A comma B ல ஈன்றது ஒரு set of points நடத்துனா at which f is not continuous ன்னு அர்த்தம். Okay, then E is of measure 0. E is of measure 0. அதே மாதிரி f equal to g almost everywhere in A comma B. என்ன அர்த்தம்? almost everywhere in A comma B னா that means in the set of points set x belongs to A comma B, f of x is not equal to A comma B ன்னு அர்த்தம் as measure 0. And f is differentiable almost everywhere அப்படின்னா என்ன அர்த்தம்? The set of points for f is not differentiable as measure 0. Okay, that is almost everywhere meaning. And there exists a uncountable subset of R1. There exists a uncountable subset of R1 that have measure 0. A classical example is the Cantor set. A classical example is the Cantor set. That is the uncountable subset of R1 as measure 0 example on the Cantor set. So which is uncountable, which is perfect, that is closed, and every point is a limit point, and which has a measure 0, which is nowhere dense, Okay, this is the Cantor set. That is a very important point. A non-empty open interval, that is how much smaller than not a matter, that is non-empty open interval is never of measure 0, because any cover of or non-empty open interval, that is because any cover of an open interval must have total length at least b minus a. Actually we need the utmost epsilon, okay, but we have that is the utmost at least on the b minus a length. That is a problem. So the non-empty open interval is never of measure 0. And these are application. Concept of almost everywhere is crucial in the Lebesgue criterion for Riemann integrability. Lebesgue criterion is a bounded function f. Lebesgue criterion, Lebesgue condition that is called the bounded function f on closed and bounded interval a comma b is Riemann integrable. A bounded function on closed and bounded interval a comma b is Riemann integrable if and only if it is continuous almost everywhere on a comma b. It is continuous almost everywhere on a comma b. Okay, this means the bounded function can have infinitely many discontinuities. Bounded function can have infinitely many discontinuities. So, there will still be Riemann integrable as long as the set of discontinuities has measured 0. The set of discontinuities has measured 0, then the bounded function is the Riemann integrable. For example, the example f of x the value is 1 for x is belongs to the set of rational number intersection with 0, 1. That means 0, 1 rational number, 0, 1 rational number. 0, 1 irrational number the function value is 0. Function value is 0. This is discontinuous everywhere on 0, 1. This is discontinuous everywhere on 0, 1. Am I correct? So that means since 0, 1 doesn't have the measure 0, 0, 1 doesn't have the measure 0, so f is not a Riemann integrable. And another function was g of x equal to 1 and x equal to 1 by n. X equal to 1 by n, the value is 1. N belongs to natural number. Okay, otherwise 0 is discontinuous only on the countable set. Countable set 1 by n, n belongs to n, union 0. Union 0, which has measured 0. Therefore, G is Riemann integrable. So, this is the example for that Lebesgue criterion. And a finite set have a measure 0, countable set have measure 0, uncountable set may or may not have the measure 0. Cantor set is uncountable but has measure 0. Intervals with positive length never has measure 0. Union of countable many measure zeros sets as measure 0. Subset of measure 0 is measure 0 set as measure 0. But A is not measure 0. But B, if B is the subset of A, B is of measure 0, then what about the A minus B? A minus B is not of measure 0. A is not measure 0, B is the subset of A, B is measure 0. So what about the A minus B in A minus B is not of measure 0. So that means assume the contradiction assume A is A minus B is of measure 0 B is measure 0 A minus B is of measure 0 by our assumption. அப்படினா A ன்றதை என்ன பண்ணலாம்னா B union A minus B ன்னு எழுதலாம். B union A minus B. Okay, so because of the it's a difference of A minus B, this is the B, ரெண்டுத்தையும் சேர்த்தீங்கன்னா we get that A. And also the given that B is the subset of A. Am I correct? B is the subset of A. So from these both B and A minus B are measure 0. Union of the two measure 0 is also measure 0. But A is not a measure 0. Ilya? So this is contradicts given that A is not a measure 0. So A minus B is of measure 0 ன்றது false. So A minus B is not of measure 0. அதே மாதிரி A less than B point. The closed and bounded interval A comma B cannot be covered by a finite number of open intervals whose length add up to less than B minus A. So use the Bain-Borel property, the closed and bounded interval A comma B, to deduce that A comma B is not of measure 0. Okay, so first of all பார்த்தீங்கன்னா the covering property பார்த்தீங்கன்னா a less than b, consider the closed interval a comma b. Suppose the contradiction assume பண்ணிட்டா there exists a finite collection of open intervals I1, I2, In such that union of the ik contains the a comma b அப்படின்னு வச்சுக்கிறோம் and sum of the length வந்து less than b minus a வச்சுருக்கோம். இப்போ a comma b ன்றது is compact. So Einborel property என்ன சொல்லுதுன்னா if such a finite cover exists with the total length less than b minus a na, then we could remove some points from the a comma b while still covering the remaining set. Okay, so இது மாதிரி ரிமூவ் பண்ணிட்டே வந்தீங்கன்னா இதில் a comma b இருந்து this leads to the contradiction because the sum of the length of the covering interval is strictly less than the length of b minus a, but every point of a comma b must be covered. This is impossible because the interval would have overlap in such a way that the total coverage is at least b minus a into the contradiction. So the ik equal to ak comma b can the maximum total length that can be covered by a non-overlapping intervals containing the a comma b is at most b minus a. So if the intervals overlap actually covered, the length is even less than the sum of their length, therefore it's impossible to cover the entire interval a comma b. So therefore length is cannot be less than b minus a. So a comma b is not of measure 0. So by the Einborel property, the contradiction a comma b is of measure 0 na epsilon equal to b minus a, and there is a countable collection of open intervals in that is union covered and the length is less than b minus a by 2. So a comma b is compact என்றதுனால Einborel theorem, there is a finite subcover that is the union of k. So union of k is less than b minus a by 2. So but this is contradicts from the part 1, therefore the a comma b cannot covered by the finite many open intervals and total length வந்து b minus a, and இதே மாதிரி a less than b na the open interval a comma b is not of measure 0. This is also the same thing, and the set of all rational numbers is of measure 0. Set of all rational numbers is of measure 0. Set of all irrational number is not of measure 0. Set of all irrational number is not of measure 0. Rational numbers பார்த்தீங்கன்னா q ன்றது set of rational number. Q is countable. Already we know that rational number is countable. So that is q ன்றது q1, q2, q3 and so on எழுதலாம். ஏன்னா countable ன்றதுனால that is 1 to 1 correspondence with the set of positive integer, that is set of natural number. So for the we want try to prove this is the set of measure 0. But for the each epsilon greater than 0 there exists a finite set of intervals. So I give the name that intervals is of the form in. For each n belongs to n, in is defined as qn minus epsilon by 2 power n plus 1, qn plus epsilon by 2 power n plus 1. இதுதான் the interval, open intervals. And q ன்றது union of open intervals all cover ஆயிருக்கணும். That is q is contained in union of in, each rational is covered. Am I correct? So that is the countable. அந்த கவுண்டபிள்ன்றதுனால எல்லா ரேஷனல் நம்பரையும் என்னால் நேம் கொடுக்க முடியுது q1, q2, q3ன்னு. ஸோ த இன்டர்வல்ஸ் வந்து என்னால் இது மாதிரி டிஃபைன் பண்ண முடிஞ்சதுன்னா ஆட்டோமேட்டிக்காக எல்லா ரேஷனல் நம்பரும் இதுக்குள்ளே இது யூனியன் ஆஃப் ஐஎனில் இருக்கும். த லென்த் ஆஃப் ஐஎன் பாருங்கள், தட் இஸ் கொண்டது எப்சிலான் பை 2 பவர் n. மொத்த லென்த்து பார்த்தீங்கன்னா தட் இஸ் கொண்டது எப்சிலான் பை 2 பவர் என்னன்னா எப்சிலானை தூக்கி வெளியே போட்டிங்கன்னா 2 பவர் என்றது ஜாமெட்ரி சீரிஸ், தட் இஸ் கால்டு தட் 1 வரும். திஸ் இஸ் த எப்சிலான். அப்படின்னா இதுவும் லெஸ் தென் எப்சிலான் வந்துடுச்சு. சம் ஆஃப் த லென்த் எல்லா லென்த்தையும் ஆட் பண்ணிங்கன்னா சம் பண்ணிங்கன்னா எப்சிலான் வருது. க்யூன்றது கம்ப்ளீட்டாக அந்த இன்டர்வல் யூனியன் ஆஃப் இன்டர்வல்ஸ் இருக்குது. ஸோ க்யூ இஸ் ஆஃப் மெஷர் 0. ஸோ தட் இஸ் அ வெரி சிம்பிள் அண்ட் வெரி இம்பார்ட்டண்ட் idea. Q is of measure 0. Irrational numbers don't have the measure 0. That means I is the set of irrational numbers r equal to q union I, that is irrational number q complement னு வெச்சுக்கலாம், ஒன்றும் தப்பு கிடையாது. The q complement னு வெச்சா that is best. So q has measure 0 நமக்கு தெரியும். Okay, the q complement, that is called the irrational number is a measure 0 அப்படின்னா, then the union is also measure 0. அப்படின்னா r contains the intervals. r ன்றது measure 0 னு வந்துரும். But r contains the interval like 0, 1. So 0, 1 is not of measure 0 னு already prove பண்ணிட்டோம். So therefore the q complement, the set of irrational number cannot be a measure 0. So the set of suppose இல்லை இது மாதிரியும் prove பண்ணலாம். is of measure 0 னு contradiction assume பண்ணிட்டு contradiction arise பண்ணலாம். And true or false, that is the f is continuous on 0, 1. g of x equal to f of x at almost every point in the x belongs to 0, 1. G is continuous almost everywhere on in 0, 1. If the statement is true, that is false because of f of x equal to 0 and x belongs to 0, 1. G of x equal to 0 for the set of irrational and a1 for the set of rational in 0, 1. இப்போ f ன்றது continuous னு கொடுத்துட்டாங்க in 0, 1. That is a constant function. G of x equal to f of x for all rational இல்லையா, almost everywhere னா rationalக்குலாம் ரெண்டு equal. The set of rational numbers, sorry, irrationalக்கு equal. Set of rational numbers in 0, 1 as measure 0. Okay, already proved. So g of x equal to f of x at almost every x belongs to 0, 1. So g is discontinuous at every point in 0, 1. The nature of the problem, g of x is discontinuous at every point in 0, 1. So in any neighborhood of any point there are both rational and irrational. So therefore g takes both values 0 and 1 arbitrarily close to any point. So the set of discontinuities of g is the entire interval 0, 1 வந்துருது. Set of discontinuities ன்றது entire interval 0, 1 which doesn't have the measure 0. So g is not continuous at almost everywhere. G is not continuous at almost everywhere. That is the proof. So that means almost everywhere equality doesn't preserve the continuity properties. Doesn't preserve the continuity properties. A function can be modified on a set of measure 0 in such a way that it becomes the discontinuities everywhere. Okay. And this is the bounds and the oscillation, that is called script m, that is called b y, that is the script y be any bounded intervals of real numbers. F ன்றது, that is the bounded function on y. We define the capital M, that is capital M of the function f over the y, that is called the supremum of the collection of the function. Okay, and small m ன்றது infimum of the function, and w ன்றது, that is called capital M, the difference of the capital M and small m is exactly the same as in the definition, that is called the 5.6, that is so y be open, that is that a is any point of y, then we can define the, this one is the infimum of the omega of f over j. Okay. So this is called a subdivision. Suppose a comma b ன்றது n points are divide பண்ணீங்கன்னா, that is like that, a equal to x0 and x1 equal to b, x1 x2 and so on. This is equivalent to x0, ఇది x1 x2 and so on. This is xn minus 1, this is called xn. So interval பார்த்தீங்கன்னா that is n intervals இருக்கும். இப்போ sigma tauன்றது are two subdivisions of a comma b. Tau is refinement of sigma. So the tau is called the refinement of sigma. Sigma complete contained in the tau இருக்கணும். Tau is obtained from sigma by adding more points of the subdivision. So sigma equal to something is a subdivision of a comma b. Then the closed interval x0, that is I1, I2, In, are called the component intervals of the sigma. How to define the upper and lower sum? The upper sum f comma sigma, upper sum of f over sigma, that is defined as sum of the maximum of the function, that is called the supremum of the function on the over the interval ik into length of the interval. Okay, இதனுடைய sum of up to n, that is called that upper sum. Okay, the lower sum is same way defined as summation of the infimum of the function over the interval ik into the length of the interval. So the upper interval is always greater than equal to, upper sum is always greater than equal to lower sum. And so that is f is bounded function, and every sum for f is greater than equal to the every lower sum, every upper sum of for f greater than equal to lower sum for f. Sigma and tau are any two subdivision of a comma b. So upper sum is always greater than equal to lower sum. And upper and lower integral, that is the infimum of the upper sum is greater than equal to supremum of the lower sum. Okay, infimum of and the supremum of the both taken overall the subdivision sigma of a comma b. And f is bounded function on the closed and bounded interval a comma b. The upper integral is defined as the infimum of the upper sum is called the upper integral, and the lower integral is the supremum of the lower sum is called the lower integral. In the case both are equal, obviously both are less than or equal, that is called the lower integral is always less than equal to upper integral. And in case of both are equal, that is called the Riemann integral. For example, lambda is the characteristic functions of the rational numbers in 0, 1. Then for any interval j is the subset of 0, 1. What is the capital M? Capital M is the supremum of the function, supremum of the characteristic function. So what is the supremum of the characteristic? Characteristic function is the, how to define the characteristic function? The x is belongs to 0, 1. The value is 1, 0, x is not belongs to 0, 1. இல்லையா? அப்படின்னா the supremum என்ன? 1, infimum என்ன? 0. Upper sum என்ன? The upper sum is the sum of the supremum of the function into length of the interval. அப்படி பார்த்தீங்கன்னா that is called that 1. Lower sum என்றது sum of the infimum of the function, that is small m, into length of the interval. இதனுடைய value 0 என்றதுனால automatically 0. So what is the lower integral? Lower integral is the infimum of the upper sum. இதனுடைய infimum of the upper sum is the, that is okay, and upper integral is the, correct, okay, lower integral is the supremum of lower sum, and upper integral is the infimum of the upper sum. Correct. So this is equal to 0. Okay, so lower integral is the supremum of the lower sum. Supremum of the lower sum is 0. Upper integral is the infimum of the upper sum, that is equal to 1. Both are not equal. So here for this example, that is simple example for the upper integral and lower integral, upper sum and lower sum, and maximum and minimum of the function. Okay, supremum and minimum of the infimum of the function கண்டுபிடிக்கிறதுக்கு. It's a very simple example. And the definition of the Riemann integrability. What is the Riemann integrable? That means upper integral and lower integral both are equal, then the function is called the Riemann integrable on a comma b. Integrability criteria na upper sum less than lower sum, that is called the Riemann integrable criterion சொல்லுவாங்க. So very first theorem, f be a bounded function on the closed and bounded interval a comma b, then f is Riemann integrable on a comma b if only if for each every epsilon greater than 0 there exists a subdivision sigma of a comma b, upper sum less than lower sum plus epsilon. That is very important one. Generally நமக்கு என்ன தெரியும்னா upper sum greater than equal to lower sum தெரியும். So in this criterion upper sum less than lower sum plus epsilon. This is a small example. But then f of x equal to x. F of x equal to x defined on the 0 to 1. Sigma under the subdivision பார்த்தீங்கன்னா 0, 1/3, 2/3, 1. I thought 3 interval of 0, 1. So what is the upper sum and the lower sum? And the 0, interval பார்த்தீங்கன்னா there is a moon interval I1, I2, I3. So the upper sum எனக்கு வேணும்னா that is called 1/3 minus 0 இதனுடைய length into இந்த intervalல supremum of the function, இந்த intervalல supremum of the function. இங்க function வந்து x, f of x equal to x. f of x equal to x னா இந்த intervalல supremum என்ன வரும்னா 1/3. okay, அதனுடைய sum. okay, that is called 1/3 into 1/3 minus 0. so 2/3 minus 1/3 into இதனுடைய supremum பார்த்தீங்கன்னா that is the 1, 2/3. இதனுடைய supremum பார்த்தீங்கன்னா 1. so 1 minus 2/3 எல்லாத்தையும் add பண்ணீங்கன்னா you get the sum result, that is called the upper sum. The same way lower sum means is the infimum of the function into length of the interval. length of the interval மேலே என்ன போட்டோமோ அதே தான், ஆனால் இதனுடைய infimum, this is called the infimum of the function product பண்ணணும். so add பண்ணீங்கன்னா we get that this is 2/3, this is 1/3. okay, இது வந்து 1/3 வருது, lower sum is the 1/3. இங்கே n belongs to I, sigma n be the subdivision 0, 1/n, 2/n, n/n of 0, 1. then limit n tends to infinity upper sum of the function f over the subdivision sigma n for the f of x equal to x. For the f of x equal to x. So subinterval பார்த்தீங்கன்னா that is the k minus 1 by n, k by n. That is k equal to 1 to and so on. So upper sum ன்றது summation k equal to 1 to n. இதனுடைய supremum of the function. ஏன்னா f of x equal to x இங்க. f of x equal to x. அதனால அதனுடைய supremum into length of the interval. இதை LCM எடுத்து simplify பண்ணீங்கன்னா that is called என்ன வரும் 1/n வந்துரும். so 1/n into k/n. so 1/n square வெளியே எடுத்துட்டா summation k, sum of the first n natural number formula n into n plus 1 divided by 2. ஒரு n cancel ஆயிடுச்சுன்னா that is called n plus 1 by 2n. limit n tends infinity upper sum ன்றது பார்த்தீங்கன்னா இதில் n tends infinity போடணும்னா மேலே n வெளியே எடுத்துட்டு கேன்சல் பண்ண பிறகு okay, so n into 1 plus 1 by n divided by 2n. n அடிச்ச பிறகு limit n tends infinity போட்டீங்கன்னா 1/2 வரும். that is called the upper sum limit n tends infinity. so the same way sigma n above, that is called limit n tends infinity lower sum என்னன்னு கேட்குறாங்க. okay, sigma n ன்றது இதுதான் 1/n like that. ஆனால் இங்கே f of x equal to x square. நான் lower sum னா length of the interval into lower sum க்கு infimum of the function k minus 1 by n whole square. so k minus 1 whole square divided by n square வந்துரும். இது வந்து 1 by n வெளியே வந்துடும். That is called 1 by n cube வெளியே கொண்டு போன பிறகு the sum of the k minus 1 whole square. So we can give the name that is called j square. K minus 1 equal to j ன்னு வச்சுட்டா அப்போ நீங்கள் j equal to 0 to n minus 1 வந்துடும். Sum of the square of the first n natural number. n into n plus 1 into 2n plus 1 by 6 இல்லையா? இங்கே n என்றது n minus 1 இங்கே. அதனால் n minus 1, n minus 1 plus 1 n ஆகிடும். அப்புறம் 2n plus 1, that is 2 into n minus 1 plus 1. That is called 2n minus 1 whole divided by 6. இந்த ஒரு n கேன்சல் ஆகிடுது, இந்த ஸ்கொயர் வந்துடும். ஸோ மிச்சம் இருக்கிறதுல லிமிட் என்ட்ரன்ஸ் இன்ஃபினிட்டி போட்டிங்கன்னா உங்களுக்கு ஆன்சர் கிடச்சிடும். ஐ தாட் இதுலேருந்து n வெளியே எடுக்கணும். 1 minus 1 by n. இங்கேருந்து n வெளியே எடுத்திங்கன்னா 2 minus 1 by n whole divided by 6n square. n square கம்ப்ளீட்டாக அடிச்சுட்டா as n tends infinity this is equal to 2 by 6 ன்னு வருது. That is called the 1 by 3. அதே மாதிரி fன்றது p naught of 0, 1 sigma nன்றது இது. And limit n tends infinity upper sum of f over sigma n, limit n tends infinity lower sum of f over sigma n both are equal to a. Then prove that integral of 0 to 1 okay f of x dx equal to a. That is a partition of p naught of 0, 1 என்றது sigma என்றது இது மாதிரி பார்ட்டிஷன் பண்ணிங்கன்னா limit n tends infinity this something limit n tends infinity upper sum and lower sum both are converges to a. Then the integral value is f of x dx equal to a. So f is a piecewise constant that is integrable. Lower sum is defined as less than or equal to something. That means supremum of the lower sum is called that lower integral, that is less than or equal to. So lower sum is less than or equal to integral 0 to 1 f of x dx. That is less than or equal to upper sum of f over sigma n. When you take n tends infinity, இதுவும் a, இதுவும் a. அப்படின்னா integral 0 to 1 f of x dx என்ன வரும்? Is also a. That is a very simple idea. Using this concept, we can get the directly. This is the answer. And f of x equal to sin x, that is defined for the 0 to pi by 2. 0 to pi by 2. Sigma n என்றது இது மாதிரி n பார்ட்டிஷனாக டிவைட் பண்ணிட்டோம். கம்ப்யூட் த அப்பர் சம் அண்ட் x equal to pi by 2n இல்லையா? அப்பர் சம்ன்றது that is called the length of the compute and show that use identity from that is something that is with x equal to pi by 2n. Show that upper sum equal to like that and prove that limit n tends infinity upper sum equal to 1 சொல்லணும். இங்கே பார்த்தீங்கன்னா upper sum பார்த்தீங்கன்னா that is called the, what is the definition? That is the maximum, that is called maximum of the function, supremum of the function on the interval into length of the interval. இங்கே வந்து kth sub interval is called k pi by 2n. So k pi by 2n minus k minus 1 pi by 2n and the kth interval into அதனுடைய corresponding function இங்கே sin x. Okay. So sin is increasing in 0 to pi by 2. 0 to pi by 2 increasing என்றதுனால the upper sum என்றது we can define the sin of k pi by 2n. K pi by 2n is called the, that is called another supremum of the function. இதில் pi by 2n இதை சிம்பிளி பண்ணிங்கன்னா LCM எடுத்து சிம்பிளி பண்ணிங்கன்னா k pi கேன்சல் ஆகிடும். I thought plus pi by 2n வரும். அந்த pi by 2n தான் வெளியே வந்துருச்சு. And sin of k pi by 2n. இதை கால்குலேட் பண்ணுறதுக்கு தான் இந்த ஐடென்டிட்டி யூஸ் பண்ண சொல்கிறாங்க. that is the summation sin k thetaன்றது. I thought 12th or 11th புக்லேயே கூட இருக்குது இது. ஸோ So sin k theta equal to sin n theta by 2 sin of n plus 1 theta by 2, that is sin theta plus sin 2 theta sin 3 theta, like that. Okay, so this is the formula, like that you can derive. It's a very simple one. So theta equal to pi by 2n. So theta equal to pi by 2n, here we get it this one இல்லையா. So sin pi by 4 value தெரியும் உங்களுக்கு, that is called 1 by root 2. இல்லை அவங்க அப்படியே யூஸ் பண்ண சொன்னாலும் யூஸ் பண்ணிக்கலாம். sin pi by 4 is the root 2 by 2, that is 1 by root 2. So the upper sum is this one. Okay, so from this we can derive this one. Okay, upper sum of this one equal to pi by 4 and sin pi by 4 y cos of something கொண்டு வரலாம். In terms of cos அவங்க prove that ன்னு சொல்லியிருக்காங்க, அதனால் இந்த டேர்மில் கொண்டு வரதுக்கு using the some formula sin A sin B formula apply பண்ணிங்கன்னா cos A minus B, cos A minus B minus cos A plus B ன்னு வரும். So we get this result. இதில் வந்து லிமிட் n tends infinity போட்டிங்கன்னா, that is upper sum is 1 by 1, that is இதனுடைய வேல்யூ வந்து 1 வந்துடும் sin theta by thetaன்றதுனால. லிமிட் n tends infinity and theta by sin theta. So the value is 1 ன்னு இல்லை sin theta by thetaன்றது, that is value is 1. So and இங்கே பார்த்தீங்கன்னா cos 0 and இங்கே பார்த்தீங்கன்னா pi by 2 plus 0, cos pi by 2 value 0, cos 0 value 1, so 1 ன்னு வந்துடும். limit n tends infinity. And f is continuous on 0, 1, then prove that limit n tends infinity 1 by n summation f of k by n. F of k by n equal to integral 0 to 1 f of x dx. When you define the function that is continuous on 0, 1, then limit n tends infinity 1 by n summation of f of k by n, summation of f of k by n equal to 0 to 1 f of x dx. Sigma n என்றது இது மாதிரி subdivision பண்ணீங்கன்னா, that is the n interval. F is continuous on 0, 1, closed and bounded interval on 0, 1. So this is implies it is uniformly continuous and integrable. So the Riemann sum is 1 by n summation f of k by n with right endpoints. They correspond to the partition, that is sigma n, with the delta xk equal to 1 by n. The sample points வந்து பார்த்தீங்கன்னா k by n. So Riemann integrable condition f is for the continuous f limit n tends infinity or n என்றது integral 0 to 1 f of x into dx. And அந்த ரிசல்ட்டை யூஸ் பண்ணி இந்த ரிசல்ட்லாம் டெரைவ் பண்ணணும். தட்ஸ் மீன்ஸ் இதுதான் ஆக்சுவலி எவாலுவேட்னு கேட்டிருப்பாங்க. ஸோ இதனுடைய வேல்யூ கண்டுபிடிக்கணும்னா லிமிட் n tends infinity 1 by n summation k by n whole square, k equal to 1 to n. So the k square by n cube, summation k square value கண்டுபிடிக்கலாம். And we know that n into n plus 1 divided 2n plus 1 by 6. So we use பண்ணிட்டு limit n tends infinity போட்டிங்கன்னா we get the result. And previous result யூஸ் பண்ணிங்கன்னா டைரெக்டாக இன்டெக்ரல் யூஸ் பண்ணிவிட்டு ப்ரொசீட் பண்ணிடலாம். இந்த ஆன்சர் சேமாக இருக்கு பாருங்க. இதனது ப்ரீவியஸ் ரிசல்ட் லிமிட் n tends infinity integral 0 to 1 f of x dxன்னு போட்டோம். இந்த இடத்துல f of xன்றது x ஸ்கொயரில் வரதுனால. இப்போ இந்த நெக்ஸ்ட் ப்ராப்ளம் பாருங்கள். இதை நீங்கள் டைரெக்டாகவும் கண்டுபிடிக்கலாம். ஐ தாட் த பெஸ்ட் வே வந்து அந்த இன்டெக்ரல் கான்செப்ட் அப்ளை பண்ணுறது. ஸோ இதை கண்டுபிடிக்கிறதுக்கு so 1 by n sin pi by n sin 2 pi by n sin n pi by n. So this is nothing but integral 0 to 1 sin pi x dx. Integrate பண்ணனா sin pi x na minus cos pi x by pi. Upper limit போட்டேனா minus cos pi by pi, lower limit na cos 0. So cos pi value minus 1, so that is called the 1 by pi, that is called the 2 by pi is the answer. That is the best way. So அதுக்காக தான் இந்த ப்ராப்ளம் கொடுத்தது. So limit n tends infinity 1 by n something கண்டுபிடிக்கணும்னா when you apply that result, that is equivalent to converges to integral 0 to 1 e power 3x into dx. So இதை integrate பண்ணிட்டீங்கன்னா we get the result. Okay. And which of the following function f for in 0 comma Riemann integral of 0 comma 1? That is the first problem பார்த்தீங்கன்னா that is the f of x equal to the characteristic function of the set 0, 1 by 10, 2 by 10, 3 by 10 and so on 1. That means 10 subintervals. The characteristic function defined. The set is finite, hence it is countable. So the bounded function is Riemann integrable அப்படினா this bounded function is Riemann integrable na if or only if, that is very important one, it is its set of discontinuities as measured 0. Set of discontinuities as measured 0. So the characteristic function of a set E is discontinuous precisely at the point at points in the boundary of E. So therefore at points that means where the limit is not equal to the function value. So E is finite என்றதனால so its closure is itself. So therefore the boundary is E itself. Therefore the discontinuities occur at these 11 points. So which is our set of measure 0. Therefore measure 0 என்றதா f is Riemann integrable on 0, 1. That is the proof. And another example is f of x equal to 1 by x, that is defined for the 0 to 1, for the 0 க்கு 7. The sign of 1 by x என்றது oscillate ஆகும் as x tends to 0 plus. So it is discontinuous at 0, discontinuous at 0, but is it discontinuous elsewhere? So for x greater than 0 எடுத்தீங்கன்னா sin of 1 by x is continuous as a composition of the continuous function. So therefore the only discontinuity is at x equal to 0, that is a single point, that is measure 0. Therefore f is belongs to Riemann integral of 0, 1, that is finite and odrum. Okay, finite set of discontinuities, that is called the f is of Riemann integral on 0, 1. That is a simple idea. And this is called the function x equal to 1 by n. N belongs to n, that is called the function value 1, otherwise 0. So the function is discontinuous at x equal to 0. X equal to 0 discontinuous and each x equal to 1 by n. So because in any neighborhood of the 1 by n there are the points where f equal to 0, and points where f equal to 1. So actually at 1 by n, that is its ones. But for m is not equal to n, 1 by m is nearby. So actually that is at x equal to 0 for any delta greater than 0, 1 by n belongs to 0 comma delta, f of 1 by n equal to 1. But f of 0 equal to 0, so that oscillate greater than equal to 1. So the discontinuity is at x equal to 0. At x equal to 1 by n, any interval around the 1 by n contains the irrational or points not form 1 by m, where f equal to 0, therefore 1 by n contains the 1 by n, therefore f equal to 1, therefore it's oscillate at the point x equal to 1. So discontinuity is equal to 0 union of the 1 by n, that is the countable set, that is measured 0, therefore f is Riemann integrable. Okay, so the எல்லா பாயிண்ட்லயும் discontinuities என்றதை டிஸ்கஸ் பண்ணிருப்பாங்க. because of x equal to 1 by n க்கு 1 னா otherwise 0 னா 1 by n என்றது 1 ன்னு எடுத்துக்கலாம். that is called that n belongs to 1 means this is 0, that is 1 by 2 and 1 by 3. Okay, like that. Okay, so in the point la the function value is 0. So what about the other point in between here? Other point la the function value is 0. இந்த பாயிண்ட்ல 1 பர்டிகுலரா. So much discontinuities are there. Okay. So அந்த discontinuitiesலாம் கலெக்ட் பண்ணீங்கன்னா what is the collection of discontinuities பார்த்தீங்கன்னா 0 and union of the 1 by n. That is the countable set. இது countable இருந்தாலும் சரி finite இருந்தாலும் சரி, that is called a discontinuity set of discontinuities countable or finite, that is called the set of measure 0. அதான் இதனுடைய ஐடியா, அதான் எக்ஸ்பிளைன் பண்ணியிருப்பாங்க. So f is belongs to Riemann integrable 0, 1 சொல்லலாம். So by the theorem, and the characteristic function of a set E is the subset of 0, 1, that is such that E and 0, 1 minus E are both dense in 0, 1, are both dense in 0, 1. So both E and its complement are dense. That means another every point x belongs to 0, 1, any neighborhood contains the points of E and the points of complement. So the characteristic function has oscillation 1 at every point. So it is discontinuities everywhere. So set of discontinuities is 0, 1. So which has a positive measure, that is measure is 1. So by the Lebesgue criterion, f is not a Riemann integrable on 0, 1. F is not a Riemann integrable on 0, 1. And omega of f of x for all x belongs to 0, 1 for each of the function f of preceding exercise, that is called the characteristic function finite set E. X is belongs to E. Any interval around the x contains the points not in E, that is value 0. The point x itself the value 1. Thus omega of f over x, that is oscillate the difference of the and supremum of the function and infimum of the function, that is called the omega of f over x. So x is not belongs to E now. E is finite. For small enough the neighborhood of x contains no points of E. So f is constant 0, so therefore omega equal to 0. So the omega of f over x, x is belongs to E now 1, x is not belongs to E now 0. So that is means omega of f over x 1, that is 1 of x, that is x is belongs to E, that is 1, otherwise 0 ன்றத define பண்ணலாம். Like that sin of 1 by x, that is equivalent to 8. That is the supremum and the difference of the supremum and the infimum. That is x equal to 0 na 8, x greater than 0 na 0. Okay. For this example, omega of f over x, that is called d ன்றது union of 0 and 1 by n. அதில் இருந்ததுனா 1, otherwise வந்து 0. This example, the omega of f of comma x 1. This is f of x equal to, f is Riemann integrable of a comma b, and f of x equal to g of x except for a countable number of points. Then g is Riemann integrable of a comma b. G is belongs to the Riemann integral of a comma b. Is it true? That is called that this statement is false. Because of that, f of x equal to 0. Already பார்த்தோம் நினைக்கிறேன் this example. So and f of x equal to g of x except the finite number of points. Then f is Riemann integrable. F of x equal to g of x ன்றது except the finite number of points. Finite number of points தான் இது true. And then g is Riemann integrable. So they differ only the finitely many points. So g is bounded and as a set of discontinuities is contained in the union of discontinuities of f. Therefore the finite points which has measured 0. So the Lebesgue criterion, g is Riemann integrable. So these are very basic idea about the Riemann integral. So the partition என்னன்னு பார்த்தோம். The partition interval divide பண்ணிட்டு, and the finite order set the p equal to x0 x1 known as the partition of phi. And எத்தனை interval இருக்கும் பார்த்தீங்கன்னா n intervals இருக்கும் அதுல. Okay. And how to define the norm? Norm means the length of the greatest of all intervals. இது மாதிரி நிறைய இன்டர்வல்ஸ் போடுவோம். இதில் எது பெரிய இன்டர்வலோ, பெரிய அதாவது லென்த்தில் எது பெரிய இன்டர்வலோ, தட் இஸ் கால்டு த norm. Okay, so the length of the greatest of all intervals IR of the partition P will be called the norm of P. That is called the mu of P னு யூஸ் பண்ணுவாங்க. So that means maximum length of the interval. Refinement means that is the ரெண்டு பார்ட்டிஷன் எடுக்கிறோன்னா, that is ஒரு பார்ட்டிஷன் வந்து கம்ப்ளீட்டாக கண்டெய்ன்ட் தான் another partition தான், that is called the every point of the partition P1 in as well as the P2. So that is called the P2 is finer than the P1. P2 is refinement of P1. Okay, ரெண்டுத்துடைய யூனியன் பண்ணிங்கன்னா is a common refinement of the P1 and P2. P1 P2 ரெண்டுத்துக்குமே refinement இருக்கும். Already refinement that is called the upper and lower sum. So the upper sum is the Riemann Steiltjes integral. Steiltjes integral Riemann integralக்கும் நிறைய டிஃபரன்ஸ் இருக்கு. ஆக்சுவலி உங்களுக்கு ரெண்டுமே சிலபஸ்ல வச்சிருக்காங்க. Okay, Steiltjes integral means with respect to the sum alpha. Okay, the upper sum of the partition P, upper sum of the function f with respect to the corresponding to the partition P with respect to the alpha, that is called a summation mr. Mr is the supremum of the function, and delta alpha r is called that the length of the intervals of the partitions. And the same way lower sum is defined as summation, it's a infimum of the function into length of the interval. But this is called the Riemann Steiltjes integral. This is called the Riemann Steiltjes sum. Okay, upper sum of P comma f comma alpha, lower sum of P comma f comma alpha are called the Riemann Steiltjes sum, and lower Riemann Steiltjes sum, this is called the upper Riemann Steiltjes sum. Okay, so that means with respect to alpha corresponding to the partition P. So already நம்ம discuss பண்ணது, the lower sum is always less than or equal to upper sum, because of the supremum of the function is always greater than or equal to infimum of the function. Okay, with respect to the length of the intervals. அதனால lower sum less than or equal to upper sum, இதில் எந்த டவுட்டும் இருக்காது. But the result ல in the case of alpha of x equal to x ன்னு எடுத்தீங்கன்னா, that is Riemann Steiltjes sum reduces to the Riemann sum. இதுதான் actually முன்னாடி பார்த்தது Riemann sum. Okay, where that is by taking the alpha of x equal to x, the Riemann integral can be easily, see that is a special case of the Riemann Steiltjes integral. Okay, all functions will be taken as bounded, and the function alpha will be always monotonic increasing. So all functions will be taken as bounded, and the function alpha will be always monotonic increasing. That is the very important point. And this is the small important theorem. P star is the refinement of the P. P star is the refinement of P, that is called lower sum of P comma f comma alpha is less than or equal to lower sum of P star comma f comma alpha. Upper sum of P star comma f comma alpha is less than or equal to upper sum of P comma f comma alpha. That is very important. Refinement வந்து greater than இருக்கும் lower sumல, upper sumல refinement less இருக்கும். Okay, இதெல்லாம் கொஞ்சம் ஞாபகம் வச்சுட்டு தான் ஆகணும். So P1 P2ன்றது be any two partition, ரெண்டு partition, ஏதோ ஒரு ரெண்டு partition. Upper sum is greater than or equal to lower sum, no doubt at all. That is, no lower sum can exceed the upper sum for generally any two partition. That is very important, very basic idea. Small m and capital M is the infimum and supremum of the function and the closed interval a comma b. Now for any partition P of a comma b, small m into alpha b minus alpha of a is less than or equal to lower sum less than or equal to upper sum, that is less than or equal to capital M into L alpha b minus alpha of A. That is very important result. And the lower and upper Riemann Steiltjes integral. So the as usual, but with respect to the partition and with respect to the alpha of the partition P, correspond to the partition P. So the lower integral is defined as supremum of the lower sum, lower Riemann Steiltjes sum of the function f with respect to alpha and corresponding to the partition P. P is a partition of A comma B. இதே இது அங்கே யூஸ் பண்ணது. ஸோ லோவர் இன்டெக்ரல் இஸ் கால்டு த சுப்ரீமம், அப்பர் இன்டெக்ரல் இஸ் கால்டு த lower integral is called the supremum of the lower sum, and upper integral is called the infimum of the upper sum, But here the Riemann Steiltjes integral, that is corresponding to the partition P, and with respect to the alpha of x is always monotonic increasing function. Okay, lower integral is always less than or equal to upper integral. Okay, and f is bounded function, alpha b monotonic increasing function. This is always true. Then for any partition P, lower sum is less than or equal to lower integral, and lower integral less than or equal to upper integral less than or equal to upper sum. So lower sum is less than or equal to upper sum. So Riemann Steiltjes integral means f and alpha be bounded function on A comma B, and alpha be a monotonic increasing on A comma B, b greater than or equal to A, and f is called the Riemann Steiltjes integral on closed interval A comma B with respect to the alpha if and only if upper integral and lower integral both are equal. Okay. So the necessary and sufficient condition, this is that. So upper sum less than lower sum plus epsilon. General upper sum greater than or equal to lower sum. So the necessary and sufficient criterion for the Riemann Steiltjes integrability, that is called f is integrable with respect to the alpha and A comma B if and only if condition for every epsilon greater than 0, that x the partition P of A comma B. So the upper sum minus lower sum nude difference is less than epsilon. Illa upper sum less than lower sum plus epsilon சொல்லலாம். Okay, முன்னாடி பார்த்தோம். This is for the Riemann Steiltjes integral. So Riemann Steiltjes sum as the limit sum, that is called that very important concept. இங்கே பார்த்தீங்கன்னா f into the bounded function, alpha into the monotonic increasing function on the interval A comma B, P into the partition of A comma B, zeta r is the rth subinterval நோடிய ஒரு point, rth subinterval நோடிய ஒரு point zeta r for r equal to 1 to n. The sum Riemann Steiltjes sum சொல்லுவோம். Riemann Steiltjes sum ன்றது how to define அப்படின்னு பார்த்தீங்கன்னா s of p comma f comma alpha summation r equal to 1 to n f of zeta r belongs to the rth subinterval into del of alpha r, that is called the length of the intervals. So that is a Riemann Steiltjes sum of f relative to the alpha on A comma B corresponding to the partition P. The sum s of p comma f comma alpha is said to be converged to L. That is as mu of p is converges to 0, partition is converges to 0, length of the partition is converges to 0 ஆகும்போது, that is norm is converges to 0 இருக்கும்போது, norm means the maximum length of the interval, அது வந்து converges to 0 னா the s of p comma f comma alpha is converges to L ன்னு அர்த்தம். That means for every epsilon there exists some delta, the s of p comma f comma alpha minus L less than epsilon when norm f p less than delta, norm p less than delta. This is the definition. And limit norm p means maximum length, that is equal to 0 இல்லையா, the greatest length of the partition of the of A comma B. So s of p comma f comma alpha exists, then f is Riemann Steiltjes integrable on A comma B, the limit norm p tends to 0 s of p comma f comma alpha integral a to b f d alpha. Okay. So that sufficient condition for the existence of Riemann-Steiltjes integral is the existence of the Riemann-Steiltjes sum. Okay, existence of the Riemann-Steiltjes sum is the sufficient condition for the Riemann-Steiltjes integral. Okay. Okay, but it can be shown that the existence of the limit is not necessarily condition for the existence of the Riemann-Steiltjes integral. F is continuous on a comma b, then f is Riemann-Steiltjes integrable, and limit norm p tends to 0 s of p comma f comma alpha equal to integral a to b f d alpha. So the continuity is the sufficient condition for the Riemann-Steiltjes integrability of the function. Okay, but it's not necessary condition. There exists a function which are integrable, but for which function is not continuous. So the continuity is the only sufficient condition, not a necessary condition. So f is monotonic on a comma b, alpha is continuous and monotonic increasing on a comma b, then f is Riemann-Steiltjes integrable. F is Riemann-Steiltjes integrable. That is also very important. So f be bounded on a comma b, c be a constant, the integral a to b f of x dc. What is the f of x dc? Okay, then p is the partition of a comma b, like that, and zeta r is the rth subinterval node at some point. Alpha of x equal to c, that is a constant. So Riemann-Steiltjes sum நம்ம கண்டுபிடிக்கணும், summation f of zeta r del of alpha r. Del of alpha r na alpha of x r minus alpha of x r minus 1, the length of the interval. Alpha of x r enna, that is c. Alpha of x r minus 1 aduvum c. C minus c enna 0. So Riemann-Steiltjes sum enna 0. Alpha of x equal to c என்றதுனால. So this is equal to 0 as norm p tends to 0 na, that is called the Riemann-Steiltjes integrable is exist. Integral a to b f of x dc equal to 0. Okay. The same way f of x equal to k. F of x equal to k be a constant function defined on a comma b. Alpha is monotonically non-decreasing function on a comma b. Then f is Riemann-Steiltjes integrable, and then prove that like that. Okay, integral a to b k d alpha equal to k into alpha b minus alpha of a. Integral a to b k d alpha equal to k into integral a to b f d alpha. So நமக்கு வேணும்னா that is called the upper sum. P into the partition, and small m or capital M என்றது infimum and supremum of the function on the rth subinterval. So இங்க infimum and supremum இது ரெண்டுமே equal to k. ஏன்னா f of x equal to k ன்னு கொடுத்திருக்காங்க. So upper sum கண்டுபிடிச்சிங்கன்னா Riemann-Steiltjes upper sum, Riemann-Steiltjes lower sum. The upper sum பார்த்தீங்கன்னா capital M r into delta r, capital M r என்றது k, அப்படின்னா alpha of x r minus alpha of x r minus 1. So இதை sum பண்ணிங்கன்னா எல்லாம் cancel ஆகிட்டு கடைசி alpha of x r minus alpha of x of x naught ன்னு கிடைக்கும். ஓகே, இதெல்லாம் cancel ஆகிடும் இல்லையா? ஸோ ஃபைனலாக இருக்கிறது alpha of xn minus alpha of x naught. xn என்றது b, x naught equal to a. So this is the answer. Upper sumக்கு. Lower sumக்கு இதே மாதிரி கண்டுபிடிக்கலாம். So upper integral is the infimum of the upper sum. So infimum of the upper sum is the same thing. Lower and supremum of the lower sum, that is the same thing. So upper integral equal to lower integral na, that is called the f is Riemann-Steiltjes integrable. So Riemann-Steiltjes integrable இருந்ததுனா that is called the integral a to b f d alpha equal to something எழுதலாம். In this case k equal to 1 na, that is called integral a to b d alpha equal to alpha b minus alpha b. So k into d alpha, that is called the k into alpha b. So both are equal. The same way for the f of x equal to x square. F of x equal to x, alpha of x equal to x square. Does 0 to 1 f d alpha exist on கேக்குறாங்க. D alpha is exist. If it exists, find its value. and 0 to 1 x dx square, that is evaluate using only the definition of the integral and evaluate the Riemann Steiltjes integral of the integral 0 to 1 x dx square. இங்கே ஃபங்க்ஷன் பார்த்தீங்கன்னா f is continuous function. ஆல்ஃபான்றது x ஸ்கொயர் கொடுத்துருக்காங்க, that is called the non decreasing function. non decreasing increasing function in 0, 1 that is increasing function இல்லையா. that is the parabolic curve. 0 to 1 that is called the increasing function is the constant function f of x, identity function, that is called the f of x equal to x, that is always continuous, no doubt at all. So that f is Riemann Steiltjes integrable. When I apply the theorem, this is the monotonic function and this is the continuous, so f is called the Riemann Steiltjes integrable. How to find out the integral value f d e alpha equal to limit norm p tends to 0 s of p comma f comma alpha. So இது எப்படி கண்டுபிடிக்கலாம், partition split பண்ணலாம் n interval ir equal to r sub interval like that, and zeta r belongs to, what is the zeta r is the r power r by n, that is the r by n, and belongs to r minus 1 by n divided by r by n. So s of p comma f comma alpha na f of zeta r, and delta of alpha r, alpha of x r minus alpha of x r minus 1. So this is the f of r by n. Am I correct? So f of r by n என்றது by the definition f r by n, because of f of x equal to x என்றதுனால. Okay. So then this is the alpha of r by n என்றது r square by n square, r minus 1 by whole square divided by n square. LCM எடுத்து simplify பண்ணீங்கன்னா we get the some result, this is equal to 2r minus 1. So divided by இங்கே n square இருக்கு, இங்கே n இருக்கு, so n cubed வெளியே கொண்டு வந்துடலாம். இங்கே r into 2r minus 1 வந்திருக்கு, so 2r square minus r. இது ரெண்டு summation split பண்ணீங்கன்னா we know that formula, அதை simplify பண்ணீங்கன்னா we get the result. Okay. So this is equal to 2 by 3 using the Riemann Steiltjes sum. Okay, as n tends infinity, இது 0 ஆயிடும், இது 0 ஆயிடும், 4 by 6 வரும், 4 by 6 is the 2 by 3. The same way f of x equal to x, alpha of x equal to sin of pi x by 2. Sin of pi x by 2, you want to integrate the f of x. So what is upper sum and lower sum? Partition is 0 to 4, only 2 interval. Refinement of p need not be decrease the upper sum or increase lower sum. So the partition 0, 4 now, that is called 0 equal to x naught and x1 equal to 2 and x2 equal to 4 இல்லையா. So 3 interval தான், red interval தான், 0, 2 and 2, 4. m1 என்றது infimum of the f in 0, 2, that is called 0, correct? And capital M1 என்றது supremum of f 0, 2, that is called the 2. Small m2 என்றது infimum of f 2, 4, that is 2. Capital f2 என்றது supremum of the f in 2, 4, that is 4. Upper sum என்றது mr delta dr. So mr என்றது that is called the m1 m2 னு பிரிக்கலாம். So m1 m2 நமக்கு தெரியும், எடுத்து substitute பண்ணீங்கன்னா upper sum. The same way lower sum, that is called the small mr into delta of alpha r. So small m1 ரெண்டே term தான் இங்க போட்டுட்டு simplify பண்ணீங்கன்னா alpha of 2, alpha of 0. Okay, that is alpha of x equal to sin pi x by 2. அது மறந்துடக்கூடாது, முன்னாடி சொல்ல மறந்துட்டேன். So the alpha of 2 என்றது that is called the sin of pi 2 by 2. Sin pi value 0, sin 0 value 0, so alpha of இது எல்லாமே 0 வருது, that is equal to 0. So the refinement பார்த்தீங்கன்னா 0, 1, 2, 3, 4 எடுக்கிறோம். This is the refinement. Refinement னா அதை விட ஒரு பாயிண்டாவது அதிகமாக எடுக்கணும், ஆல்ரெடி இருக்கிறத விட ஒரு பாயிண்டாவது அதிகமாக எடுக்கணும், that is called the refinement. இங்கே 1, 3 னா ஆன்சர் பண்ணிக்கோ, 0, 2, 4 கொடுத்துருந்தாங்க, that is called இங்கே only 1, 3 ஆட் பண்ணிக்கோ. ஸோ refinement of p. So m1 equal to infimum of the f on 0, 1, m2 ன்றது infimum of f and 1, 2, 2, 3, 3, 4. So capital M1 capital M2 ன்றது supremum of the function corresponding intervals. இங்கே interval பார்த்தீங்கன்னா 1 2 3 எதனா வரும், that is called the 4 intervals வரும். எல்லாத்துக்கும் infimum and supremum அந்த corresponding interval கண்டுபிடிச்சிட்டு upper sum lower sum for the refinement கண்டுபிடிக்கலாம். So both are same இருக்கு. Okay, so that is the refinement of need not be decrease and upper sum. And lower sum பார்த்தீங்கன்னா lower sum the same way same இருக்கு. That is the refinement not increase the lower sum. That is the idea. அதே மாதிரி 0 to 3 x dx இங்கே greatest integer function. So இங்கே alpha of x ன்றது greatest integer function, not exceed x. That is a so இங்கே பார்த்தீங்கன்னா alpha of x equal to x 0,3 ன்றது interval. So 0 to 1 1 to 2 2 to 3 like that define பண்ணிங்கன்னா for that for the 0 to 1 க்கு alpha of x equal to 0. ஏன்னா 0 க்கு 1 கடையில் 0 தான். alpha of x equal to 1 1 to 2 க்கு alpha of x equal to 2 ஏன்னா greatest integer function less than or equal to x. நீங்கள் 1.5 எடுத்தீங்கனாலும் that is equal to 1 தான். Okay, so 0.2 எடுத்தீங்கனாலும் the value is 0. அதனால தான் இந்த இன்டர்வலில் 0, இந்த இன்டர்வலில் 1, இந்த இன்டர்வலில் 2, 3 போட்டிங்கன்னா 3 தான் வரும், 1 போட்டிங்கன்னா 1 தான் வரும். ஓகே, ஸோ the partition வந்து 0,3 இது மாதிரி ஸ்ப்ளிட் பண்ணலாம். n இன்டர்வலாக பார்ட்டிஷன் பண்ணிங்கன்னா எல்லாத்தையும் டிவைட் பண்ணும் பொழுது ஓகேவா the length of the interval into the something. Okay, m1 del alpha 1 there is r equal to 1 to l minus 1. l இன்டர்வலுக்கு தனியாக ஸ்ப்ளிட் பண்ணியிருக்கோம். Okay, the same way here for that 2 into 2 minus 1, that is called so 0 equal to x naught. Okay, the partition 0 equal to x naught, n is subinterval, x1 x2 x3 xl minus 1 along, that is called the point 0 point something, 0 point something value. Okay, 0.1 0.2 0.3 like that. xl equal to 1, xm equal to 2, xn equal to 3. இதுக்கு இடையில இருக்கிறதுலாம் 1 point something, இதுக்கு இடையில இருக்கிறதுலாம் 2 point something. So அதனால தான் that is split into the like that. Okay, so the value exist ஆகிறது L க்கு மட்டும் தான் exist ஆகும். That is the maximum value is another supremum of the function on that interval, that is called the 1, and the length of the interval 1 minus 0. மீதி எல்லாத்துக்கும் 0 minus 0. alpha of delta of alpha ன்றது 0,0 வரும். இங்கே delta of alpha ன்றது 1 minus 1 ன்னு வரும். இங்கே delta of r ன்றது that is called the 2 minus 2 ன்னு வரும். Okay, இங்கே மட்டும் தான் 1 minus 0 2 minus 1 and 3 minus 2 ன்னு வரும் at the point 1 ல. ஸோ அதனால் உங்களுக்கு ஆன்சர் வந்து பார்த்தீங்கன்னா 0. ஸோ integral 0 to 3 upper integral value infimum of the upper sum. Infimum of the upper sum is equivalent to is called the 6. Okay, P is the partition. இதே மாதிரி lower sum கண்டுபிடிக்கலாம், அதுவும் 6. ரெண்டு ஈக்குவல்னா that is called the Riemann Steiltjes integrable. Then integral 0 to 3 x into d greatest integer function x equal to 6. Okay, alpha ன்றது increases on a comma b and is continuous at x naught. X naught is lies between the a to b. So another function f is such that f of x naught equal to 1 and f of x equal to 0, x is not equal to x naught. Then f is Riemann integrable with respect to alpha over the a comma b. So integral a to b f d alpha equal to 0. So then இங்கே என்ன கொடுத்துருக்காங்க, that is a function defined f of x naught equal to 1 and f of x equal to 0 for x is not equal to x naught. f of x equal to 0, f of x naught equal to 1. f ன்றது Riemann integrable சொல்லணும் and integral of f d alpha equal to 0. So this is the partition. So f of zeta r equal to 0 for the zeta r is not equal to x naught. Equal to x naught, the value is 1. இதனுடைய value 1 del of alpha r வந்துரும். So s of p comma f comma alpha equal to 0 for this one not equal to x naught. Equal to x naught, that is less than epsilon. So the integral of f d alpha equal to limit non p tends to 0, that is equal to 0. So f is Riemann integrable, Riemann Steiltjes integrable over a comma b. When I define the function like that, f of x is bounded on minus 1 comma 1 and beta of x defined like that. X less than 0 na 0, x equal to 0 na 1, x greater than 0 na 2, like that. Inge f of x is Riemann Steiltjes integrable with respect to beta of x. With respect to beta of x on minus 1 comma 1. If and only if f of x is continuous at x equal to 0. F of x is continuous at x equal to 0. Inga Riemann Steiltjes sum with respect to the beta kandupidichina, this is the formula. Okay, with respect to beta of xi minus beta of xi minus 1. So the jump at beta of x, the partition of t, that is called the difference is 0, the difference is 1, and I equal to r minus 1, I equal to r na, the difference is 1, I greater than r na, that is called the difference is 0. Okay, so both are greater than 0, x are greater than 0, like that, and the function defined manada porutha. S of p comma f comma beta that is equivalent to f of zeta r 1 minus 0, that is called the f of zeta r minus 1 plus f of zeta r. In case when both are equal to 0, this is equivalent to f of 0 plus f of 0, that is called the 2f of 0. In the case of norm p tends to 0, the length is maximum length is 0 na, then xr minus 1, xr both are converges to 0 plus, that is the limit of this one is exist, and if this is both are converges to f of 0, that is zeta r minus 1, that is s of limited norm p tends to 0, s of p comma f comma beta is equals to 2 times f of 0 if these both are equal to, that means f is continuous at x equal to 0. Okay, so f is Riemann integrable with respect to beta on minus 1 comma 1, this is must be exist, and f must be continuous at x equal to 0. Then integral value is 2 times f of 0. Okay, result ஆ கூட ஞாபகம் வச்சுக்கோங்க. ஓகே, இவ்வளோ காம்ப்ளிகேட்டட்லாம் கேட்கறதுக்கு வாய்ப்பு கம்மி. தட்ஸ் லைக் தட், இது மாதிரி ப்ராப்ளம் கேட்கலாம். ஓகே, இது மாதிரி ப்ராப்ளம் இருக்கிறது கொஞ்சம் ப்ராக்டிஸ் பண்ணாங்க. ஓகே, சரி, நாளைக்கு பார்ப்போம் மிச்சத்தை.